The final trig properties that we're going to prove is the sum to product identities. They have a proof of the sum to product identity. So the sum of two signs, that one is right down here. I'm going to take this one and I'm going to show you the difference of two cosines and how we can write it as product. So it's the cosine of alpha minus the cosine of beta is equal to a negative 2 times the sine of alpha plus beta divided by 2, then times the sine of alpha minus beta divided by 2. Okay. Now, in order to prove this, what they do is they make a substitution principle immediately. So this is going to be represented x, and this is going to represent y, and we rewrite this as negative 2 times the sine of replacing alpha plus beta divided by 2 by x, so sine of x, times, then we got a sine of y. Okay? Now at this juncture, what they do is they go back and they use sine of a product. So we're going to write a product as a sum. So we're going to rewrite this as a product of a sum. Give me just a moment. I'll be right back with that. Alright, so at this point, we're going to rewrite it as negative 2 times. Now this, the sine of a product, we're going to write it as a sum. So this is a product to sum identity. It says it's equal to, put in a half, we take the cosine of alpha plus beta. Now I'm going to substitute our alpha and beta are x and y. So x minus y, then minus the cosine of alpha minus beta, so that's going to be x plus y. Close it. So then what we're going to do is we're going to immediately come right back and we're going to replace what x and y represented. So sliding it over a little bit, negative 2 times a half, and we got to take that times the whole thing here. I didn't get that extra set in there, so half times the cosine of. Now we're going to do the replacement back with what x was. X was alpha plus beta divided by 2. And we're going to subtract it what y was, which was alpha minus beta divided by 2. Then minus the cosine of x represented alpha plus beta divided by 2, plus, and y represented alpha minus beta divided by 2. Bracket, bracket. So I'm going to go ahead and take this negative 2 times a half, and it's just going to be a negative parenthesis, or bracket, cosine of. Now inside here we already have common denominators. I'm going to distribute the negative sign, so that's going to be minus alpha, and it's going to be plus beta. So now we're going to collect terms in here. So that's a negative alpha plus an alpha, which is 0. Beta plus beta is 2 beta all over 2. Then we're supposed to subtract from that the cosine of. Doing the same thing here, we're just collecting our like terms. That's 2 alphas. And our betas are going to cancel all over 2. Then we're going to come back and we're going to cancel out our 2's. So we have a negative sign sitting out front there, the cosine of beta minus the cosine of alpha. We still have to distribute our negative, so it's going to become a positive alpha minus the cosine of beta. So that is the derivative of the cosine of the sum to a product.